Normal indications. This is verbiage that comes right out of the FAA test question that's been altered to just kind of reflect what you might see for a question. With the accumulator installed and the gas chamber charged, main system hydraulic pressure gauge will not show a hydraulic pressure reading until the fluid side of the accumulator has been charged. It doesn't say charged to a specific pressure, but you do have to have a drop of hydraulic fluid in the accumulator in order to be able to read a pressure. Okay. All right. With gas pressure per liter of 1,000 psi, when the hydraulic system pressure of 3,000 psi is developed, the pressure on the gas side of the accumulator will be 3,000. So again, I operated that hand pump from zero pressure. I went to 400 psi, that drop of fluid entered it, continued to use the hand pump, more fluid entered. It compressed that initial 400 psi to whatever value I now see on the system pressure gauge. So that's what we're talking about. 3 possible ways to verify gas pressure. I've shown you 2 of them. One of them, if the engine is inoperative, but the system still has hydraulic pressure, operate a hydraulic unit slowly and note the pressure at which a rapid pressure drop begins as it goes towards 0. So again, we've already got system pressure developed. You have to catch the gauge before it goes right to 0. So if it's an engine-driven pump, all you have to do is stop the pump and, okay, whatever pressure you got, then use the selector valve to make an actuator work. Whatever pressure it was at before it dropped to 0, that is the gas pressure in the accumulator. All right. And the other method, with 0 hydraulic system pressure, operate a hydraulic pump and note the point at which the hydraulic pressure stops building quickly and begins to build slowly. So again, you watch for the quick rise going up, and then at some point, from that point on, it continues up very slowly. If you're using a engine-driven pump or an electric pump other than a hand pump, you can still do it, but you have to be kind of quick. And lastly, if you have a gauge on the gas side of the accumulator, this is your last option. Obviously, you reduce the system pressure and look at the gauge. So if you reduce the fluid pressure by using the selector valve again, send the fluid back to the reservoir. If there's a gauge mounted on the gas side of the accumulator, obviously that measures the gas pressure. Okay, a little bit on troubleshooting. Remember all the things that we talked about as benefits for hydraulic accumulators. They supplement the pump under peak loads. They provide for emergency source of fluid. They keep the accumulator, they keep the unloading valve in the kicked out position. They suppress leakage. They prevent pressure spikes when you close selector valves. If you start to see symptoms where those things start to happen, usually the root cause of that is loss of gas charge in the accumulator. So, okay, but let's talk about a few other things as well. You open that service valve up, or you depress the valve core if it's got a valve core in the service valve, then you see fluid coming out. What's the problem? Yeah, you've got a ruptured diaphragm bladder or maybe a leaking piston seal. So you've got fluid escaping to the gas out of the accumulator. Pressure is available when the pump is running, but not available when the pump is stopped. It usually traces itself back to the loss of the gas charge in the accumulator. So again, the gas charge is gone. Loud hammering noises, regulator cycles more frequently than usual. Also maybe an internal leak in the circuit. Okay, all of those things possibly lead me to a leaky service valve. So you've lost the gas charge. By the way, too, how could you specifically detect that the service valve itself is leaking? The service valve. What would you do to check that? Soapy water. If you put a little bit of soapy water on that valve, you shouldn't see any bubbles coming from it, right? All right. So if you want to check the valve itself for leaks, okay, simple to do, soapy water. Okay. A little bit of process on accumulators. Sometimes some systems will have a valve that's called a manually operated check valve. Remember I told you earlier that fluid takes the path of least resistance? Let's say you're using a hand pump to try to power down maybe an emergency landing gear for emergency extension. And there's an accumulator that's in that same circuit. do you suppose which would move first? Would the bladder and the accumulator move first, or would the landing gear attempt to come down first?
Bladder.
Yeah, the accumulator. So again, the fluid would try to fill the accumulator before it sees any other load. So what they have in some circuits, they've got a valve that can be positioned so that it cuts the accumulator off and kind of isolates it when you use the hand pump. That valve is called a manually operated check valve. I'll show you a picture of it in a minute. There's another thing you should know too. Although accumulators provide for some benefits on a hydraulic system, it's not a perfect world. The simple fact that you do have an accumulator means that it can sometimes hide or a malfunction that may be in a hydraulic circuit. And the example that I give during the checkout for accumulators is you use the hand pump, you develop system pressure, and then I use that little hand wheel that's in the pressure manifold, and I cut off system pressure. In a perfect world, you should be able to hold system pressure even though that valve is shut off, but there's a leak. If you take a look at this, there's a leak already on the floor, you can see it. But, okay, so I've got system pressure established. If I close the valve off, all this does is it removes the accumulator from the pressure manifold. So you shut the hand wheel off, and lo and behold, the system pressure gauge goes to 0. Now, you put the accumulator back in the pressure manifold, hey, miraculous, the pressure comes back. The problem is that that accumulator is hiding that leak. If it were an internal leak, it'd be even more difficult to deduce that because you can't see the fluid that's dripping on the floor. So again, the purpose of the accumulator is to suppress leakage and prevent system pressure from going to 0. But again, you've got an internal leak or an external leak, and it's doing exactly what it's supposed to do. So it makes troubleshooting a little bit difficult if you've got an accumulator. If you've got an internal leak, maybe the relief valve is leaking internally, you can't see that leak, but the fluid is going back to the reservoir, but the accumulator is still trying to maintain that system pressure. Do you all kind of see that? All right. Okay. Overcharging the preload of an accumulator may prevent the accumulator charging with fluid. That gas that's in the accumulator is a resistive charge. The fluid has to react against it in order to enter into the accumulator. So what that means is if you didn't follow the servicing instructions and gas that thing to the limit, and maybe you put 3,000 psi in the accumulator when the system pressure is supposed to be regulated at 1,500, there's no way in hell that any fluid will ever enter into the accumulator. So again, it's just like not having the accumulator in the circuit. Okay, so again, kind of important. Gas leakage past an accumulator diaphragm, bladder, or piston may cause erratic pressure indication. It's one thing for the gas to be leaking out of the service valve. However, it's possible also if the bladder or the diaphragm has got a hole or some type of a defect in it, that the gas is going to find its way into the fluid. Now it becomes entrained in the fluid itself. The problem now is that gas finds its way into the pressure manifold, and that any component where the gas is present, the gas is going to attempt to expand. In the case of an actuator, it's going to lead to jerky or regulator actuator motion. So you operate the selector valve, you start to see the actuator kind of do this. The problem, you probably, some of the gas has left the gas out of the accumulator. It's now found its way into the fluid, and because gas is compressible, it provides a jerky motion on the actuators that moves back and forth. The other thing that it may do is, if that gas bubble finds its way into the board-on tube of the pressure gauge, as soon as it gets there, the gas will begin to expand. It'll make the pressure gauge read in an unstable way. The pressure may start to creep up. There's a board-on tube. As the board-on tube begins to expand, it causes the needle to begin to rise. This particular bladder, this Maka was replaced by me many years ago. The bladder came out of, that was supplied with a Maka, had a hole in it that wasn't detected until maybe about a week or so after it arrived. So I found an accumulator in the shop that had an equivalent style of bladder. I put that one in. But the root cause of that indication that when the gauge pressure started to rise, it was a result of the gas bubble of nitrogen getting into the board-on tube. So just remember that. Stuck accumulator piston may render an accumulator inoperable. So if you've got a piston type accumulator and the cylinder itself in fact becomes damaged in any way, obviously the piston can't move back and forth. the accumulator is not going to function at all. Anything else that's kind of unique? Oh, by the way, too, for overhaul of an accumulator, a piston type accumulator, one of the specified tests for return to service is going to be a friction test. What they have to do is they have to verify that the piston will slide freely inside of the cylinder. So they may use gas pressure or fluid in order to verify that the piston slides back or forth. Question?
What's the best way to detect internal leakage?
Internal leakage of what?
Of any component?
Internal leakage, you're getting caps and plugs for some systems. Like say, for example, you suspected maybe that relief valve was leaking internally. What you might want to do is bridge it out of the circuit, remove it just by using caps or plugs or jumpers, and see if you can raise system pressure to the point where the pressure is held. You're doing, for troubleshooting, the best examples I can give you are electrical examples, where you have like a short circuit or an open circuit in an electrical circuit. You're doing the same thing hydraulically. So an open circuit would be the same thing as a leak. And what you would do is you could check for voltage at particular points if you've got an open circuit. And if you've got a short circuit, that would be like a direct short back to from power source to ground. I don't know if you'd have some, I guess you would. Usually in that particular case, it would be a problem with the regulator or the unloading valve. But you could use caps, plugs, or jumpers in order to be able to figure out where you've got an internal leak. They're very difficult to find. Okay. Okay, so you got the basics of how this thing kind of works, right? You know what the accumulator kind of does?
Yeah.
Right. Here's that MOCV, that manually operated check valve. In some early aircraft designs, the function of that device was to isolate the accumulator when you use the hand pump. So you can see they've got a engine-driven pump, they have an accumulator, and they've got a pressure regulator in the circuit. But from the pressure manifold, both the pump and the accumulator are available to provide hydraulic power to maybe power brakes, landing gear, wing flaps, whatever you have. The problem is, if you want to use the hand pump, the fluid flow that comes out of the hand pump has an easier opportunity for being able to replenish the fluid and replenish the accumulator, because it's easier to, or at least it affords an easier path of entry into the accumulator rather than try to lower landing gear down or whatever component you might have used. So what they use is a manually operated check valve. It's a bypass check valve in many ways. In normal operation, what it does is it allows the flow from the accumulator to exit. However, if we wish to cut the accumulator off, we just what we do is we just bias the check that's inside of the valve one way, and the flow from the hand pump cannot enter back into the accumulator. It's forced to go directly to operate the components that are in the pressure manifold. So that's how it works. Okay. What questions do you have? Any questions on hand pumps or on accumulators? Nothing? Would you like to see a few FAA test questions?
Yes.
Okay, all right. Supplements the pump under peak loads, right? What you think? Okay.
See,
Yeah, all you have to do is get a drop of fluid in it, in the accumulator, it's considered to be charged with fluid. B is right.
D for sure.
What's the answer?
C.
C.
Which one is C?
What do you think?
B.
Nah, you fell for the trap.
C. I know, C.
Yeah, there's no such thing as a fluid preload. What you lost is the gas charge, a leaking service valve.
B.
Okay, got that. What do you think? Not B, A. If it has one, right? If it's got a gauge on the gas side, all you do is reduce system pressure. Whatever pressure you're reading on that air side of the gas side of the accumulator is the gas charge.
High pressure.
C.
Relieve system pressure.
C.
Yeah, you've lost what? Pre-charge, right?
Air reload. There's no such thing.
That's what they, all I can do is give you what they got. I can't rewrite their questions. What do you think?
B.
A.
Pressure.
Pressure.
What's the more
C.
likely?
A.
What's more likely, A or C?
C.
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 The more common thing is you've lost the gas charge. Maybe the service valve is leaking.
Say preload right there, not pre-charge.
Just the way that they've termed it. Oh, you don't know that. I don't know if you know that.
I do. A.
Goes beyond the cumulative. Let's see if we can find a few on hand pumps. I think you've got the hand pump questions with the regular pumps. Let's see if I have them. Which check valve has been done incorrectly?
C.
The one inside the piston, right? The outboard check valve. What do you think?
C.
Anybody?
C.
I think that's about it. All right. What, any other questions? Anything you have on hand pumps or accumulators? Question?
That manual check valve to prevent the fluid going back into the accumulator. Why wouldn't it just be a check valve, period? Why does it have to be?
You wouldn't have a way to bias it. In other words, it's normally held, you're opening it up against the spring for normal operation, and you're closing it off. What you're doing is you're closing it in order to be able to prevent the fluid from getting back into the accumulator.
Right. But if it was just a one-way check valve, wouldn't that work the same way?
Well, you wouldn't ever be able, if you wanted to, be able to use the hand pump to get the fluid back into the accumulator.
Oh. So if there are times where.
Yeah, you know, just like, anything else, if you want to charge the accumulator back up again for whatever reason, you need the check valve there for really both purposes, not only to isolate it, but also to allow, when you want it, to get the fluid back into it. All right. I guess I'm done. I finished a little bit earlier than I should. You sure? No questions? Okay, I'll see you out in the lab then. Okay?